In this video, we are going to be talking about systems of linear inequalities. So a system of linear inequalities is basically where we have two or more linear inequalities. And the solution of this system, so unlike where the lines meet, as in regular linear equations, so a system of linear equations where they meet, it's going to be where the shading overlaps. So again, since we're talking about linear inequalities, the best way to show solutions of these is to actually go and sketch a graph of it and then look at the shading. So this time we're just going to have two or more lines with two or more pieces of shading, and we're going to look for the overlap, and that overlap is where our solutions live. So here are some examples. So in the first one, you can see that we have two linear inequalities. So this red line, we can see a couple things. We see that it's dashed, so we know it's not or equal to. We know that it is y is less than because everything is shaded below it. And with the blue line, we see that it is an or equal to because it's solid, and also it's going to be a y is less than because everything below it is shaded. So you can see that the overlap is happening in this location right here. So you can see anywhere in this shaded region is where our solutions live. So this point right here is a solution. This point of 2, 1 is a solution. This point over here of 0, 0 is a solution. This point over here of 2, negative 3 is a solution, so forth and so on. Anything in this shaded, and also anything on this solid blue line that is less than the dashed one. So nothing on the dashed line counts, but anything on the solid line would also work as a solution. So on the second example, so again, you can see that this mix of blue and tan or whatever color that is, cream, I don't know. This is where solutions live. So this point over here would not be in that overlapped region, so this is not a solution. But anything over here would be, as well as anything on this red line, as long as it's below the dashed line, but nothing on the dashed line would work. So let's go into some examples and do it ourselves. So here we have two linear inequalities, and we want to find or give two ordered pairs that are solutions to these linear inequalities. So the first thing we're going to do is actually graph them. So before I can graph this top one, I need to rearrange it so that it is in slope-intercept form. So I'm just going to come over here to the side, and I'm going to solve for y. So the first thing I would do is I would go and add 3x on both sides. So on the left side, those would cancel, leaving me with 2y. 3x and 2 are not like terms, so I'm just going to leave them as 3x plus 2. So plus 2, since it was a positive 2, I put the x first because this is how it is in normal standard form. So the last thing I need to do is I just need to divide both sides by 2, which is the same as dividing every single term that you see by 2. So on the left side, that's just going to cancel. On the right side, I'm going to keep that fraction of 3/2 because we're talking about slope, and 2 divided by 2 is just 1. So now we have that in slope-intercept form, and the second equation is also in slope-intercept form. So I'm going to put this one in blue graph, this one will be a green graph. Let's see, I'll do shading in yellow for this one, and I'll do shading in blue in this one because I think blue and yellow make a nice color. Yeah, they make green, so that would be a great thing to see that overlap. So let's start and graph that first one. Oops. I'm going to make my Cartesian plane, which is your xy plane. So we have a y-intercept of 1. So I'm going to come over here to 1, put my dot. We're talking about a slope of 3 over 2. So that means I'm going to go up 3 and right 2. So from here, I'm going to go up 3 and right 2. I'm going to flip both signs so I can also go in the opposite direction. So a negative 3 over a negative 2 is telling me go down 3 and left 2. So from the point, I'm going to go down 3, left 2. I can do that again because I have room. So I need to figure out whether or not to make this a solid or dashed line. And since I have the or equal to, this is going to be a solid line. So now I need to do my shading. And since this is a greater than symbol, I'm going to shade everything above this line. So then now I need to do the second line. So it's already in the slope-intercept form. So it had a y-intercept of 3. So I'm going to come up here to 3, drop my point. It has a slope of 4 over 1. So that is telling me I'm going to go up 4 and right 1. So if I go up 4, 1, 2, 3, 4 over 1, I'm up in this words. So I'm going to go and flip both the signs of that slope, so a negative 4 over a negative 1, and relook at it. So it's telling me to go down 1, left 1. So from my y-intercept, I'm going to go down 4 and left 1. And do it again. I'm going to go down 4, left 1. And then now I can draw my line. I need to figure out if it's dashed or solid. So I do not have the or equal to. So this is going to be a dashed line. Again, don't forget your arrows at the end. And then I need to figure out where I need to shade. So we have the less than symbol. So that means I need to shade underneath it. So underneath that would be me going down from any point. So since this one's steep, it may be kind of hard to see, but if you pick any point on the line and you go down with it, that's the area you need to go and shade. So again, if I just go straight down, it's telling me I'm going to be shading over here. So I'm going to come with my blue shade, I'm going to shade everything underneath the line. That's good enough. And there, you can see that I have this green section that is where my answers live. So I just need to pick 2 of those points. So I'm going to pick this point right here, and that point seems to be about positive 2, 1, 2, 3, 4, 5, so 2, 5, and it wanted one more. So I'm going to pick the one on the solid line because it's also in the blue section and it is part of the blue line solution. So since it's solid, I can pick this point. If it was a dashed line, I cannot pick any point on a dashed line. So I'm going to pick that point right there, and that point seems to be about 2, 4. So those are 2 points. You could have also picked any other point that would have been in that green region. So that is graphing systems of linear inequalities and finding their solutions. So if you don't have highlighters that give you a nice little mix of colors, one thing you could do is do horizontal shading for one and vertical shading for the other one, so horizontal and vertical, and then when you combine vertical and horizontal, you get a nice little crosshatch. So anything in the crosshatch would be the answer. So again, if you don't have a highlighter, do one vertical and one horizontal, and then wherever you see the crosshatch, that's the answer. So here are 2 for you to try. And when you come back, I will give you 2 points in the solution, and you can see if those 2 points also work as yours, or maybe those were the 2 points you found as well. So pause this video and try it out. All right, welcome back. So the 2 points that I found were 0, 0 and -5, -5. So again, I'm not saying those are the 2 points that you should have gotten, but as long as my 2 points that I said fit in your shaded area, your overlap of shaded area, that means you're correct.